Welcome back, my dear students. In this session, we'll learn chapter number 15, Introduction to Graphs. Chapter number 15, Introduction to Graphs. Okay, let's study this chapter number 15 now. Bar graph. A bar graph is used to show comparison among categories. It may consist of two or more parallel, vertical or horizontal bars, rectangles. Following is the bar graph of Prabhat's mathematics mark obtained in 3 terminal examination. Now let us see this bar graph. This bar graph shows Prabhat's mathematics mark obtained in 3 terminal examination. This is terms. This is first term, this is second term, this is third term. And this is marks in mathematics. So in the first term, Prabhat is getting 25 marks. Here is 20, here is 30, and this middle is 25. So the height of this bar graph reaches up to 25. So in the first term, Prabhat is getting 25 marks. In the second term, this is second term, and this height of the bar is reached up to 30. So in the second term, Prabhat is getting 30 marks, and in the third term the height of this bar reaches up to 45. This is 40, this is 50, and the middle is 45. So this represents Prabhat's marks obtained in 3 terminal examination. While drawing bar graph, in between 2 bars there is gap. This is gap, this is gap, and this bar represents the mark obtained by Prabhat in first term, second term, and third term. Bar graph can also have double bars. Here this bar graph shows double bar graph. Here is 2, here is 2, here is 2. So this is an example of double bar graph. Okay. Next is a pie chart or circle graph. This is an example of pie chart or circle graph, circle chart. A pie chart is used to compare parts of a whole. This circle represents the whole. Figure 15.2, this is figure 15.2 is a pie graph. This is a pie graph. It shows the percentage of viewers watching different types of TV channel. So this is entertainment 50%. So this half of the circle represents entertainment, that is 50%, and sports 25%. This represents sports, and this dark color represents news, that is 15%, and this is informative 10%. And this is an example of circle chart or pie chart. Next is histogram. A histogram is a bar graph that shows data in interval. It has adjacent bars over the interval. This is an example of histogram. Illustration 1. The histogram in figure 15.3, this figure 15.3 illustrates the distribution of weight in kg of 40% of a locality with kg number of persons. 40 to 45 4%, 45 to 50 12%, 50 to 55 13%, 55 to 60 6%, 60 to 65 5%. And if we want to draw a histogram, then we can draw like that. This is weight in kg. This is 40 kg, 45 kg, 50 kg, 55, 60, 65, 70 kg, so on. And this is number of persons. So here is 0, here is 2, 4, 6, 8, 10, 12, 14, so on. And 40 to 45 is 4%. So here is 40, here is 45, and this bar graph reaches up to 4. and this 45 to 50, this is 45, this is 50, and this bar reaches up to 12. This is 12, so this is 12 up to this mark. Then 50 to 55, this is 50, this is 55, and this bar will reach up to 13. Here is 12, here is 14. So in between, this middle is 13. Next is 55 to 60 is 6. So here is 55, here is 60, and since here is 6, this bar will reach up to 6. So 6 mark line is this. So this bar reaches up to that. Next is 60 to 65, and this is 5%. So 60 to 65, and this bar will reach up to 5. This is 4, this is 6. In the middle, this is the mark of 5. So like that, we can draw the histogram. And the difference between histogram and bar graph is that when drawing histogram, there is no gap in between the bars. Here is a bar, here is bar, here is a bar, here is a bar, here is a bar. But in between, there is no gap. But in case of bar graph, this is bar graph, this is bar, this is bar, this is bar. In between bars, there is gap. But in histogram, there is no gap in between the bars. So here, this is histogram, and there is no gap in between the bars. So you see here, there are no gaps between bars because there are no gap between the interval. What is the information that you get from this histogram? Try to list them out. Okay, note in figure 15.3, in this figure, a zigzag line, there is this line, this is the mark, has been used along horizontal line to indicate that we are not showing numbers between 0 and 40. Here is 0 and here is 40. So in between these two, we have not shown any number. So we represent this by putting a zigzag line. This is the zigzag line. And next is a line graph. A line graph displays data that changes continuously over a period of time. Here, illustration 2, time 6 a.m., 10 a.m., 2 p.m., 6 p.m. and temperature is degrees Celsius, 37, 40, 38, and 35. This we can draw as a line graph. Let us plot these points on the graph. So when time is 6 a.m., temperature is 37. So in the graph you see here, this is time, and this is temperature 0 degrees Celsius. So at 6 a.m. temperature is 37. Here is 36, here is 38. So in between, this middle is 37. So this point represents at 6 a.m. the temperature is 37. Then next is here, when the time is 10 a.m. the temperature is 40. So 10 a.m. temperature 40 degree. So 10 a.m. is here, 10 a.m. is here, and temperature is here is 40. So this is the mark of 40, and this point represents at 10 a.m. the temperature is 40 degrees Celsius. And next is at 2 p.m. the temperature is 38 degrees Celsius. So again we can plot this on the graph paper. So here, this is 2 p.m. and here temperature is, this is the 38 mark, so 38 degrees Celsius. So this point represents at 2 p.m. the temperature is 38 degrees Celsius, and this point represents at 6 p.m. the temperature is 35. This is 34, this is 36. In between these two, this middle is the mark of 35. So this point represents at 6 p.m. the temperature is 35 degrees Celsius. So this at 6 p.m. the temperature is 35 degrees Celsius. Then we have to join this point and this point and this point and this point. If we join these points, then we are getting this. So we are getting a line like that. And this is an example of how we draw a line graph. A line graph. Now let's try exercise 15.1. Question number 1. The following graph, this graph, shows the temperature of a patient in a hospital recorded every hour. A. What was the patient's temperature at 1 p.m.? B. When the patient's temperature 38.5 degrees Celsius. So in this question number A, we have to find out what was the patient's temperature at 1 p.m. So here is time, here is temperature, and there is degrees Celsius. So at 1 p.m. we have to find out the patient's temperature. So here 9 a.m., 10 a.m., 11 a.m., 12 noon, 1 p.m. is here. So this is 1 p.m. So at 1 p.m. this is the line drawing, and this point, if we are moving this side, and this point represents 36.5. Here is 36, here is 37, and this middle point is 36.5. So for this question number A, the patient's temperature at 1 p.m. was 36.5 degrees Celsius. Now exercise 15.1 solution. A. The patient's temperature at 1 p.m. was 36.5. degrees Celsius. Next is question number B. When was the patient's temperature 38.5 degrees Celsius? Okay, now let's see in this graph. This is 38.5 degrees Celsius, and 38.5 degrees Celsius is 34, 35, 36, 37, 38. 38.5 degrees Celsius is this. And if we are moving on this line, we go this point, and if we go this below, then this is 12 noon. So at 12 noon, the patient's temperature was 38.5 degrees Celsius. So the answer is 12 noon. So the answer is 12 noon. So now B, the temperature of patient was 38.5 degrees Celsius at 12 noon. Question number C, the patient's temperature was the same 2 times during the period given. What were these 2 times? Okay, now let's write this. Now let's see in the graph. So at these 2 points, the temperatures are same. So at this point, the time is 1 p.m. and at this point, the time is 2 p.m. The patient's temperature was same at 1 p.m. and 2 p.m. 2 p.m. What was the temperature at 1:30 p.m.? How did you arrive at your answer? Now the time is here, the given time is 1:30 p.m. and at this 1:30 p.m. we have to find out the temperature. Now let's look in the graph. So here is 1, here is 2, and in between this is 1:30 p.m. So this is 1:30 p.m. and in this line, if we go, then this is the temperature. So at this point, the temperature is 36.5 degrees Celsius. The temperature at 1:30 p.m. was 36.5 degrees Celsius because the temperature between 1 p.m. and 2 p.m. is same. Also, graph between 1 p.m. and 2 p.m. is a straight line parallel to x-axis. Similarly, the point on the y-axis between 36 degrees Celsius and 37 degrees Celsius will represent 36.5 degrees Celsius. Next is question number E. During which period did the patient's temperature show an upward trend? So, you see in this graph, from 9 a.m. to 10, the temperature is going upward. Again, from 10 to 11 a.m., again the temperature is going upwards. Then down, 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 again upwards. So from 2 p.m. to 3 p.m. also the temperature is going upwards. So we can write question number E answer 9 a.m. to 10 a.m., 10 a.m. to 11 a.m. and 2 p.m. to 3 p.m. the temperature is going upward. So here question number 1 is over. Question number 2. The following line graph shows the yearly sales figure for a manufacturing company. So this graph shows the sales figure for a manufacturing company. Now A. What were the sales in Roman 1 2002, Roman number 2 2006? So in 2002 and in 2006 we have to find out the sales. Now B. What were the sales in Roman 1 2003, Roman number 2 2005? So in 2003 and in 2005 we have to find out the sales. Next is C. Compute the difference between the sales in 2002 and 2006. Question number D. In which year was there the greatest difference between the sales as compared to its previous year? Okay, now let's try to solve this question. Now question A. What were the sales in Roman 1 2002? So in 2002 you see this is years and this is sales in rupees crore. So in 2002, so if we go through this line, here is the point. So this point is coincide to the sales 4 crore. So this is 4. So in 2002 the sales were rupees 4 crore. Question number 2, solution A. Roman 1. Sales in 2002 is equal to rupees 4 crore. Now Roman number 2, 2006. So in 2006 the sales is this point. If we go this side, this is 8, so 8 crore. So Roman number 2, sales in 2006 is equal to rupees 8 crore. Now B. Question number B this. What were the sales in 2003? So in 2003 the sale is 7 crore. So rupees 7 crore. Now 2005. So in 2005 the sale is this point and this is 10 crore. So rupees 10 crore. Rupees 10 crore. Question number C. Compute the difference between the sales in 2002, that means this A Roman 1 2002 and 2006. That means question number A Roman number 2 2006. So question number C. The difference between the sales of 2002 in 2002 rupees 4 crore and 2006 2006 is rupees 8 crore. So 8 minus 4 crore. If we subtract 8 minus 4 is 4 crore. So 4 crore is getting. Question number D. In which year was there the greatest difference between the sales as compared to its previous year? So in this graph we see that the distance between these 2 points is the longest. So this is longer, so again this is longer. So the longest distance is between these 2 points. So this point is for 2004 and this point is for 2005. Now the greatest difference between the sales of 2 consecutive years was 2004 and 2005. That is 2005, and 2005 is the answer. Now let's see question number 3. For an experiment in botany, 2 different plants, plant A and plant B. This is plant A. This dotted line represents plant A and plant B represents by this line. Were grown under similar laboratory conditions. Their height were measured at the end of each week for 3 weeks. The results are shown by the following graph. So this graph shows that the growth of plant A and plant B at the end of each week for 3 weeks. So this is weeks. This is week 1, this is week 2, this is week 3. And this is height in centimeter. So this is 2 centimeter, 4 centimeter, 6 centimeter, 8 centimeter, 10 centimeter, 12 centimeter, 14 centimeter. So plant A is represented by dotted line, and plant B is this line. Now question number A. How high was plant A after Roman 1 2 week, Roman number 2 3 week? Now we have to observe the graph and we have to answer this. How high was plant A after Roman 1 2 week, Roman number 2 3 weeks? Now let's look in the graph once more. So this dotted line represents growth of plant A. Now this is first week, this is 2 weeks. So in the second week, the growth of plant A is this point, and this height is, here is 6, here is 8. So this is 7 centimeter. So question number 3, solution A, Roman 1, height of the plant A after 2 weeks is 7 centimeter. So in the end of 3 weeks, the height of the plant A is this point, and this point is at the height of 9 centimeters. This is 8, this is 10, so this is 9 centimeter. So height of plant A after 3 weeks is 9 centimeter. Okay, now B. Height of plant B after 2 weeks. So after 2 weeks, this line represents growth of plant B. So this is 2 weeks. At the end of 2 weeks, the height is this point, and this is 7 centimeters. So B, Roman 1, height of plant B after 2 weeks is 7 centimeters. Next is height of plant B after 3 weeks. So this is at the end of 3 weeks, and the height of plant B is this point, and this is at the height of 10 centimeters. So height of plant B after 3 weeks is 10 centimeters. Now question number C. The plant A grows during the third week is 9 minus 7 centimeters. That is, if we subtract, we are getting 2 centimeters. Now question number D. The plant B grows from the end of second week to the end of the third week is 10 centimeters minus 7 centimeters. If we subtract, we are getting 3 centimeters. Now question number E. During which week did plant A grow most? Now let us study in the graph. This dotted line represents the growth of plant A. If we are studying this dotted line, we see that these two distance is the longest. this point and this point. This 2 point is the longest. So when we compare these two distance and this is longer. Again, when we compare these two and these two, this is longer. So this is first week and this is at the end of second week. So in this second week, the growth of plant A is most. So now question number E, second week. Now question number F. During which week did plant B grow least? And if we study the graph, that is first week. So first week. Now question number Z. Where the two plants of the same height during any week shown here specify. Now let us see in the graph once more. This dotted line represents growth of plant A, and this line represents growth of plant B, and these two growths are coincide at that point. That means at the end of second week. Z, now we have to write down both the plants have shown the same height at the end of second week. Here question number 2 is over. Now question number 3. For an experiment in question number 3 is over and question number 4 is same. So now let's write question number 5. This. Use the table below to draw linear graph. For this question number 5, we have to use the given graph and we have to draw linear graph. A. The number of days a hillside city receives snow in different years. Year 2003, 2004, 2005, 2006. Days, 8 days, 10 days, 5 days, 12 days. Now we have to draw this linear graph. Linear graph means we have to draw the graph as line. Now question 5A solution. Snowfall received in different days during the year in hillside city. Year 2003, 2004, 2005, 2006. Days 8, 10, 5, 12. Now to draw the graph, we have to draw this first. A vertical line and a horizontal line. And this horizontal line represents years. This is 2003, 2004, 2005, 2006. And this is days. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This represents the days. Now let's see the table. So in 2003, this is 8. So here is 2003. So through this 2003, we have drawn a line. And this is 8 days, so again we are drawing a line and we are getting this point. So this point represents in the year 2003 8 days. So this point represents 2003 year and days 8. And next is 2004 and 10. This is 2004. And we are drawing a line and this is 10 day and we are getting this point. And next is 2005 and 5. So this is 2005 drawing a line and this is 5 days and we are getting this point. And next is 2006 and 12 days. So this is 2006 and we are drawing a line here. And 12 is here. So if we draw these two lines and we are getting this point. So we are getting now 4 points. This point, this point, and this point, and this point. Now we have to join these points. If we join this point, we are getting this linear graph. So here, question number A is over. Question number B is same, so you try this. Question number 6 also same, so you try this. Now let me do this question number 7. Can there be a time temperature graph as follows? Justify your answer. Here Roman 1, Roman number 2, Roman number 3, Roman number 4 are given. And the question is asking that, can this graph be time temperature graph? Now let's see Roman number 1. This is time, this is temperature. So this arrow represents the graph. So here the temperature is increasing, and this is the time. So here the temperature is increasing from here. Then the temperature is coming here and here and here and here. If we write the temperature, this may be 1, 2, 3, 4, 5, so on. So here the temperature is increasing due time. So this can be time temperature graph. Question number 7, now Roman 1. Yes, it may be a time temperature graph because with change in time, temperature may increase. For example, during daytime in summer. During the daytime in summer, the temperature is increased. So that Roman 1 can be time temperature graph. Now this is Roman number 2. This is time and this is temperature. Here the temperature is decreasing. At part the temperature is here. Then it is decrease. This also can be time temperature graph. Roman number 2. Yes, it may be possible that with change in time, temperature may be fall uniformly. Now let's see Roman number 3. This is Roman number 3. Here, this is time, this is temperature. Here at the same time, the temperature is increasing. So this is not possible because at the same time, it cannot have different temperatures. So this cannot be time temperature graph. So this Roman number 3 cannot be time temperature graph. Roman number 3, no, there are infinite numbers of temperature at the same time. This is not possible. Now Roman number 4. This is Roman number 4. This is time, this is temperature. So here temperature is fixed and time is different. So this can be time temperature graph. Roman 4. Yes, temperature can be same for a period of time. Hence, case 3, this case 3 does not represent a time graph. And here it is over. Time temperature graph. Here, this question number 7 is over. Here, exercise 15.1 is over. In the next session, we'll learn exercise 15.2. Okay, all of you, thank you.